Hello, and thank you for coming to our presentation on intravenous WBC monitoring and warning systems. My name is Sam Mather, and I worked on this project with Cleo Cadwell, Stephen DeFreitas, and Mikhail Herson. So currently, over 30 million non-cardiac surgeries occur every year. And of those surgeries, 1.8% die within 30 days of getting the surgery completed. And of those 1.8%, 5.8% die of infection. So currently in hospitals, there is no way to track symptoms for infections other than physical symptoms looked at by the attending doctor or lab tests only when instructed to be done by the doctor. There is no monitoring system in place to let us catch the early signs of an infection and to stop the infection from growing and become resistant to antibiotics.
Our current strategy is to build a small, locally implantable MEMS device that uses a specifically sized aperture and measures fluid resistance in real time to count the patient's neutrophil levels and transmit that data to a remote system that will interpret the data and report it to the physician and patient if a notable change appeared that requires intervention. Our current design is based off of existing research that has used this technology to count blood cell types from a prepared blood sample over a short period of time. Our goal is to improve upon this design by housing the technology in a small device that can be placed locally to the wound site to monitor the circulatory activity at a specific site. We aim to make this device easily implantable and removable so that the device will only be present in the patient for the time for which it is required. Our efforts are directed at creating an early warning system for the physician and patient both, such that signs of infection or other immune disturbances can be caught before the patient becomes symptomatic or worse.
Our device will be implanted during surgery and will offer an early detection of the abnormal activity of immune cells within the body. This abnormal activity will indicate an infection, which will be signaled to both the patient and the hospital. If the patient is currently in the hospital, treatment can be applied as needed. If the patient is at home, our device will offer 24/7 monitoring and will be able to signal to the patient that they must return to the hospital for further treatment. Our product has an estimated cost of production range between $120 and $200. This stems from the list of items below, which are needed in order to create one monitoring device. The cost of computer processing will depend on the amount of data we are receiving from each device. The cost of glass casings will depend on the manufacturer.
Currently, there are no clinically used complete blood count or white blood cell count devices available, so our only competition would be doctors physically looking for signs of infection and then ordering a blood cell count to be done on the patient. There's also some examples of microfluidic chips that can do blood cell counts by taking a small amount of blood from a patient and running it that way, but these are also not available for clinical use. Our only limitations would be, in a biomechanical sense, electrode corrosion, as the articles that we have based this off of have not seen any corrosion presently, but they have not been exposed to the body for long enough for it to be definitive that corrosion wouldn't occur, as well as things such as shear force from the blood hitting the implant when it's been implanted in a vein. Our audience is mostly people who are the most susceptible to infections, so people recovering from surgeries, people who have HIV and AIDS need to have their white blood cells monitored constantly, people in remission for cancer, as well as people with a history of autoimmune disorders.